Hey guys, Coach McCullers here. This is the lesson on function notation. And what is function notation? Well, if you printed your graphic organizer, you have a space for a definition at the top. And I'm going to explain what a function is for you right now. A function is a special type of relationship between an input and an output, where the input is called the domain, and that corresponds to exactly only one output or range value. So, what is a function? A function is a relationship between two values, and for every input or domain, you get only one output. Okay? Now, what is function notation? Well, to kind of explain that to you a little bit, I'm going to have you meet a couple people, a couple friends of mine. So let's go meet them now. Hey guys, I want to introduce you to Mrs. F of X. Mrs. F of X teaches math here at North Oconee. You might know it's Miss Jet, but that's not her real name. It's Mrs. F of X. What I have here is I have some inputs, and I'm going to give it to Mrs. F of X. She's a function. Her name is F. Okay. Now, when I give her these inputs, she's actually going to do some computation. She's been programmed to do these particular adjustments to numbers. So I'm going to give her an input of 3. So the X value, or the domain value, is going to be 3, and Mrs. F of X is going to work her magic, and she spits out a 4. Okay, input value is 3, domain, output value is 4. So what we say here is F of 3 gives us a 4. That means Mrs. F of X took the 3, spit out a 4. Okay, let's give her another input, negative 2. Okay, Mrs. F of X, F of negative 2 would be, thank you, negative 11. Now you may be wondering, what is F of X? Well, F of X is just a fancy way of writing a function. If I turn Mrs. F of X around, the way she's set up is she takes the number, multiplies it times 3, and subtracts 5. So if we check ourselves here, input of 3 times 3 is 9, and 9 minus 5 gives us the 4. If we input a negative 2, negative 2 times 3 is negative 6, minus 5 gives us negative 11. Okay, thank you, Mrs. F of X. All right, guys, I want you to meet another friend of mine. This is Mr. B of X, or Coach B of X, you should call him, our head basketball coach here at North Oconee. Coach B of X is defined to be x squared plus 2, which means he's going to take the input values, he's going to square them, and he's going to add 2 to them. Okay, so let's give Mr. B of X a input of 5, a domain of 5. So there you go, Mr. B of X. See those gears working up there? Excellent. So input of 5, Mr. B of X takes that number and outputs a 27. Excellent. So what we have there, or what we write in function notation, is that B of 5 is equal to 27. Excellent. Put in a 5, get out of 27. 527 would be the order pair. Let's test Mr. B of X out one more time. We're going to give Mr. B of X a negative 4. Mr. B of X, do your magic. Excellent. Computation is brilliant. Negative 4 squared is 16. 16 plus 2 is 18. There you go. Mr. B of X knows his stuff. All right, put in a 4, get out of 18. In function notation, we write B of negative 4 equals 18, which gives you the order pair negative 4, 18. All right, thank you, B of X. Okay, guys, let's continue on our graphic organizer. We're going to determine if the next 2 statements are representative of a function. Okay, number 1 says, you are selling candy bars as a fundraiser. Is there a relationship between the number of bars sold and the resulting income? The input there, or the X value, would be the number of bars that you sell. And the output, or the range value, would be the resulting income. So, think about that. For every input value, there should be a distinctive output value. The more bars you sell, the more money you get. If you don't sell a lot of bars, you're not going to get as much money. So that one would be a function. Okay. Number 2 says you have 10 coins. Is this a relationship between the number of coins and the value of the coins? Is this a function? Well, think about that. Now we have coins, penny, all the way up to even a dollar coin in our U.S. denominations. Think about 10 coins. It could be a combination of a lot of different types of coins. Let's say we have a total of 25 cents. Well, 25 cents can be represented with 1 coin, with 2 coins, no, not 2 coins, with 3 coins, or 4 or 5 coins, or a combination of each. So we can get the same result by having different amounts of coins. So that one would not represent a function. Okay? The next section. Functions are often named by letters as ways of referring to the whole relationship between inputs and outputs or domain and range. For example, we can represent a function by the name f, and I think we met f earlier, which represents some set of ordered pairs. The first coordinate can be represented by x, and the second coordinate y will be represented by f of x, or the function notation. Thus, every ordered pair x comma y can be rewritten as x comma f of x. Remember, this is a special way of writing y. X represents the domain values, and f of x represents the range values. Okay? The next example says we can evaluate functions by looking at a set of ordered pairs. And in that example, we give you the order pairs 4, 2, 6, 3, 8, 4, and negative 10, 5. Negative 5. I'm going to write those down right here. 4, 2, 6, 3, 8, 4, and negative 10, negative 5. Okay? If I would like to find h of 8, okay, if this is function h of x, and it includes all of these points, then what I'm asking for is what is the output value when the input value is 8? So when the input value is 8, I get an output value of 4. What is h of negative 10? What is the output value when the input value is negative 10? In this case, it would be negative 5. Okay. The next two examples work backwards. This is asking, what is h of x if h of x is 3? I give you the output value, it's asking for the input value. So where is the output value or the range value 3, and the input value in this case is going to be 6. Next problem is h of x equals negative 5. X has got to equal negative 10. If I get an output value of negative 5, the input value has got to be negative 10. Okay? At the bottom of the page, you're going to find 3 examples. Go ahead and fill out those examples, and I'll see you tomorrow.